Okay, so good morning. Today's lesson is all about trace tables, which is how on paper we can debug an algorithm and work through how it all works. So we want to work out how we can use a trace table to see how variables change as we go through each line in code. And we need to think about different types of errors. So the easiest errors to find are those syntax errors, because as soon as you write them and press run, you get an error message. The next easiest one to find is a runtime error, because it might run and then crash and give you an error message. The hardest ones to find are logic errors, because the only way to find a logic error is by running your program and seeing if it does what you want. And the best way to do that is stepping through. Either stepping through with your IDE one line at a time, setting breakpoints and stepping over your code, or as we're doing today with trace tables. So here's a worked example. We have some Python code here. We've got a table, and this is going to be a trace table. In your trace table, sometimes you have variables, sometimes you have expressions, and sometimes you have output. An expression is just what it is in maths. It's a combination of values and variables and functions. So we'll see what that means as we go. So we have as many rows as we need. You can have as many as you like. And the idea is we step through one line of code at a time. So I'm currently on line 1. I've just run line 1. Because I've assigned the value 0 into the variable num1. Okay, so I'm stepping through in my trace table. Just run line 2 to put that 0 into the variable called num2. This is assignment. Next thing that's going to happen, you're probably predicting down here, we are going to put that 5 into num1. So what happens here? We don't cross it out, but we'd go on to the next line in our trace table so that we can see that variable did store a 0. It's now been overwritten with a 5. So whenever a variable changes, you move on to the next row. Okay, what's going to happen next? Well, here for the for loop, we're going to set count to the first value in range 3, which is going to be 0. So we're going to set count to 0. Notice we don't need to bother writing anything in here because num2 hasn't changed. It's still 0 because we set it to 0 at the top. Then what's going to happen? Well, we need to work out what num2 is. And even though it's still 0, I'm going to write it in. Why? Because we've calculated it. How did we calculate it? Well, we did num1 multiplied by count. How do I know what num1 and count are? Well, my trace table tells us. That's nice, isn't it? 5 multiplied by 0, anything multiplied by 0 is 0. That value gets stored in num2, so we write it in our trace table. This is on a different row. Some people might put it on the same row, but I think it's sensible to put it on a new row because, well, if anything changes, you move on to the next row. Here I didn't put it on a new row because it's kind of that one's changed, that one hasn't changed. You kind of read from left to right, don't you? So that one's changed next. But if I then put that as a 0 there, I'd probably think, well, that num2 had changed before count. So that's why I moved on to a new row here. All right, so what happens here? Count has gone up to 1. Why? Because we've got a for loop. Count was set to 0 up here. We've done that line. We go back round the for loop, set count to 1, and we can see it in the trace table. What's going to happen next? Well, this time we do num1 times count. Num1 is 5, count is 1, 1 times 5 is 5. Pop that in num2, and hopefully you've got the idea now. This continues until count is 2, and at this point we don't need to step through anymore. We can see the pattern because 2 times 5 is going to be 10. And then our for loop is finished because remember, for something in range goes up to but not including that value. We've done 0, 1, 2, that is 3 times, but not including 3. So the final thing will be to display something. What's going to be displayed? Well, our trace table makes this easy because we can see what is currently in num2. So output is going to say 10. So you could have put that on the same row or you could put it on the next row. I would suggest always putting it onto the next row if it's like in the next section of code. So that's it really. That's what a trace table does. You just need practice on it. So we are on CT7 today. we have got a similar algorithm. You've already got your trace table set up. Count is going to be set to 4, and then number is going to be set to 0, and then you need to complete the rest of the trace table. So the Word document you need is in Activities and Homework CT7, so that's half term 8. And the one that you want is this one, CT7 Activities. Could you please make sure that you rate your confidence for all of the learning objectives in half term 7, Algorithms and Programming 7 for me, please? So there's quite a few learning objectives to go through. Notice you have done most of them already. So the new ones, the ones that we're focusing on today, are to do with like stepping through programs, tracing through programs. So once you've done activity 1, please go to Algorithms and Programming 7 and rate your confidence for me, please. So I'm really sorry, I told you the wrong thing before. It should be half term 8 progress checker to do. We're going to go through activity 2 together. It's a slightly more complicated algorithm. In some ways, but in some ways it's easier. We don't have any iteration here, we just have selection. So we start off with some variable initialization. We get some input, we've got some selection, and then we've got some output. So let's have a look and see what we need to do. An algorithm's been designed to validate, that means check and make sure it's sensible, separate parts of a code, as in stuff that a user enters in, not programming language code. The user enters the first part of the code, 2 characters, and then the second part of the code, which is 4 digits. The algorithm calculates a score reflecting the validity. Is it valid or is it not valid? Skip over the algorithm for now. This is what we want it to do. So this is a test table that says if I type in WB followed by 1, 2, 3, 4, it should say valid input 4. If I say 1, 2, then 1, 2, 3, 4, then it's invalid because it should be 2 characters, I think. So here we go. Use trace tables to demonstrate that the algorithm generates the predicted output when supplied with the given input. You can indicate an empty string using a hyphen symbol, double quotes, or empty. So we've got a choice here. So case 1, which means this one here. Notice I've tried to get it 2 on a page, otherwise you're going to be constantly scrolling up and down. So let's start at the top. Score is set to 0. Nice. Code 1 is set to an empty string. Well, these are all in initialization. I'm going to put them all on the same line. They're empty strings, open and close quotation marks. But it said you could have said a hyphen or empty. I'm going to go for open close quotation marks. Then code 1 is input. Enter a string of 2 characters. Well, this is case 1, so the user types in WB, and that gets stored in code 1, WB. It's a string, so I'm going to put it in quotation marks. Code 2 is going to be enter a number of 4 digits, 1, 2, 3, 4. I'm not going to put this in quotation marks because it gets passed through the int function, which converts it to an integer. So I'm now up to line 8. Right, what happens? If code 1 square bracket 0 is more than A, and so there's a lot going on here, what I'd normally do is add an extra column for both of those expressions. There's not really space for it, but I would have done code 1 square bracket 0 as the first column, and then another column for code 1 square bracket 0 is greater than A. But let's try and do it all in one, shall we? What does it mean? Code 1 square bracket 0 means the first character of code 1, which is W. Is W more than A? Yes, it is. Let's have a look at the next one. Code 1, 0 is less than or equal to 0. So is W, first character of code 1, less than or equal to Z? Yes, it is. W is less than Z in the alphabet. So basically, this line is saying, is it a letter, a capital letter? If both of these conditions are met, so that's true and that is true, so therefore that and that is true, so we'll run this. Score equals score plus 1. So score is going to be 1. If the the character at position 1 So that's going to be B. Remember, it's 0 indexed. So if we do code 1 square brackets 1, it's not code 1 square brackets 0, it's code 1 square brackets 1, the second character. So is B a capital letter between A and Z? Inclusive, because it says greater than or equal to A, or less than or equal to Z. So both of those conditions are met, so therefore the score goes up. All right, code 2 is 1, 2, 3, 4. Is that bigger than or equal to 1, 1, 1? Yes, it is. Is it less than or equal to 9, 9, 9? Yes, it is. If score is not equal to 4, well, score is equal to 4, so I'm going to ignore that. Else, well, I'm not going to ignore that. Print valid input score. So that is what we display. Valid input 4. So you need to do the same kind of thing for case 2, case 3, and case 4. Okay, so we're going to go through activity 3, or at least make a start on it. So it says there's an algorithm to sum the numbers in a one-dimensional data structure, and it has an error. So what does that mean? Sum means add them up. A one-dimensional data structure, well, we've got a list, and it's got an error. We need to probably work out what the error is. First of all, we need to complete the trace table to identify the error. You may not need all the rows. That's good. Okay, so let's do our initialization. Let's start at line 1. Remember, in an exam, you'd probably put your finger where my mouse cursor is, or you'd put a pencil or a rubber or something just to keep track of which line you're on. So num table isn't in our trace table, so I'm not going to put it in. Index is set to 0. That's line 2. Line 3 says length is set to 0. It's all initialization, so I'm going to put it on the same line. Total is equal to 0. There we go. Then I've got a paragraph break, so I'm definitely going to move on to the next line. Length is equal to len num table minus 1. So len is a built-in function in Python. It calculates the length of something. What is it calculating the length of? Num table. What's num table? It is a list with 1, 2, 3, 4, 5 characters in. So the length of num table is 5. 5 minus 1 is 4. So where does that go? That goes in length. 4. Right. While the index is less than length. So index is 4, index is 0, length is 4. So therefore this Boolean expression, this thing here, is going to be true. So my while loop runs. Total, the new value of total, is going to be set to the old value of total, which is currently 0, plus num table index. So what is num table index? Well, let's calculate it. Num table is a list. Index is 0, so that means the first value of num table, which is 9. Right, so total equals total plus num table. Total was 0, we're adding 9 to it, so total is going to be set to 9. Index is going to be index plus 1. I'm going to move on to a new line for this because I don't want to go backwards. And then let's see if we need to go back around our while loop or display the result. We'll see. While index is less than length. Well, index is 1. Length is 4. So index is less than length. That evaluates to true. So my while loop goes. Total, the new value of total, so I'm going to need something in here, is equal to, well, I've gone back around the while loop, so I'm going to go on a new line. The new value of total is going to be the old value of total, which is 9, plus the value in the num table list at position index. So index is 1. That means 0, 1. Num table square brackets 1 is 8. So 9 plus 8 is 17. Then we increase index by 1 on line 10. Pop that down there. And I'm going to stop there for you to work out the rest. Your job is to go through the trace table, compare the output with what the algorithm said it was supposed to do, and see if you can fix it. And then when you've finished, please make sure that this gets submitted onto it's Algorithms and Programming 8 on the VLE for me, please.